Alright guys, so what we're starting today is chapter 2.1, quadratic functions and models. So analyzing graphs of quadratic functions, writing quadratic function standard form and using the results to sketch the graph, minimum and maximum, and we won't focus too much on application. So the first thing is going to be the graph of a quadratic function. In this section you will study the graph, so on and so forth. Ax plus b, this is the same as y equals mx plus b. So for this here is the same as y equals mx plus b. It's just a linear function. F of x equals c is a constant function, so this could be any number like 6. So we could say f of x equals 6. It's a constant function because it makes a straight line across. So on a graph, it would look something like this. Now f of x equals x squared gives us our u-shaped graph. It's kind of our quadratic. It's a type of quadratic. It's just called a squaring function because we're just squaring a number. So those are our kind of main graphs. Now, a quadratic graph of quadratic function. The definition of a polynomial function is this here. So this is defining, get a highlighter. This here is just defining any higher degree polynomial function. Now, probably at some point I've already showed you a graph or this written out here in Algebra 2 because I showed you this. I wrote this all the way out. This is a higher degree polynomial function. Any degree. It doesn't matter what it is. But this here, just this part that I just highlighted in green, is a quadratic. Because if we have that, it means we're talking about quadratic functions. Because the highest degree is 2. So polynomial functions are classified by degree. For instance, a constant function, f of x equals c, has degree 0. Linear has degree 1. In this section, we'll study quadratics because they have a degree 2, or second degree polynomial. Now, all of these here are quadratic functions because they're all degree 2. Note that the squaring function is a simple form of the quadratic. It's just a very simple form. It's a simplest form that we can have. It's what we call the parent function. But these are also all quadratics. They're just a little bit more to them. They have some more numbers and elements to them. Now, definitions of this: ax squared plus bx plus c is called a quadratic function. It's a parabola. It makes a U shape. Looks like a satellite dish or flashlight reflectors. Now, all parabolas are symmetric with respect to a line called the axis of symmetry, or simply the axis of the parabola. So the axis of symmetry is the line for which it is mirrored across. And the distance from that line, so this distance, is going to be the same on either side. No matter where we're at on the parabola, it'll be the same distance. The vertex is either the lowest point or the highest point in the parabola, depending on the value of a. If a is positive, it's going to open up. If a is negative, it's going to open down, the leading coefficient. And the leading coefficient is always talking about the variable in front of the, sorry, not the variable, the number in front of the variable with the highest power, the highest degree. And we have these here. When the leading coefficient is positive, the graph opens up. When the leading coefficient is negative, so when a is negative, it opens down. If its graph is a parabola whose vertex is 0, 0, so on and so forth, this is our basic function. So positive, negative opens down. Ax squared, our squaring function. So we're not going to actually graph these, but we can look at this here. So x squared and 2x squared. So the light gray one is x squared, so 2x squared is having an increase. All the values are increasing by a factor of 2. And when it opens up, so on and so forth, and we can have these rigid transformations we've talked about before. The graph of y equals xx can be translated to produce one of these two here. And we talked about this in last chapter, and we'll focus more on it kind of next chapter. Now, standard form. This is something we will focus on in looking at here. The standard form of a quadratic function comes in this form here. And we've seen this because we talked about this in Algebra 1. We talked about it a little bit last chapter when we talked about transformations of quadratics. A parentheses x minus h parentheses squared plus k, where a is our vertical stretch or shrink. H is when we move it left or right. and k is moving it up or down. And we want it in this form to kind of help us out, because what this tells us is it identifies the vertex of it as h comma k. The vertex is going to be h comma k. Let me get my highlighter to highlight some of the stuff. Whose vertex is the point h comma k. Now it also tells us the axis of symmetry, whose axis of symmetry or axis is the line x equals h. And a is equal to greater than 0 is opens up, and a is less than 0 opens down. Now, our first example is this here. Now, if we notice this here, f of x equals 2x squared plus 8x plus 7 is not in that form. A times x minus h squared plus k. It's not in this form here. It doesn't show up in this form. So what we have to do is we have to rewrite it in this form. So this is going to be one way we can do it, and then we'll come across a different way to go about solving these later. But we're going to do it in this way first. So what we're going to do first is I'm going to put parentheses around 2x squared plus 8x plus 7. Because what we're wanting to do first is we want to create this a times x minus h squared. We want to create this here. Now the first thing I'm going to do is I'm going to factor out 2. I want x squared by itself. Because here x is by itself, so I need x squared to be by itself. So I'm going to factor out 2 from both of these terms. And when I factor it out, well, 2 out of 2x squared leaves me with just x squared. And when I factor 2 out of 8x, I'm left with plus 4x plus blank minus blank plus 7. Now, you're probably wondering, okay, why in the heck did you leave 2 blanks here and here? Because again, what we want is a set of parentheses, so x minus h in parentheses squared. And what this is a sum of perfect squares or difference of perfect squares. Well, it's a sum or difference of perfect squares. So we have a set of parentheses squared. Now, the way to get this is we're going to go back to our set of, we're going to use completing the square. And you probably remember this from Algebra 2. Hopefully you remember it from Algebra 2, doing completing the square. Because that's what we're going to do here to rewrite this set of parentheses here. This thing here as a set of parentheses squared. As a set of parentheses squared. Now to find the C term, or to find the term that goes in these 2 spots here, we call it C, is equal to B over 2 squared. Now our B term for us here is 4. And well, 4 over 2 is 2, and 2 squared is 4. So we want to put 4 here. Because x squared plus 4x plus 4 is a perfect square, or we can rewrite it as a set of parentheses squared. But if you notice, I just added 4 inside of these parentheses. Well, I can't just add 4, I also have to subtract 4. Because this here is a fancy way of saying 0. I'm not added anything, because I added 4 and I subtracted 4. So they're offsetting each other. So that's what we've done so far. Now, what we're going to end up doing is we're going to end up rewriting this here as a set of parentheses squared. We really don't need the negative 4. So what we're going to do is, this is going to seem a little bit odd, is I'm almost going to move it outside of the parentheses, like this here. But the only way I can move it outside of the parentheses is if I multiply it by 2. I'm not going to multiply the whole thing by 2, because we're still going to have 2 parentheses x squared plus 4x plus 4 minus 8 plus 7. So the reason that we did the 2 minus 4, 2 times negative 4, is to get it outside of the parentheses. which we did. Because again, when we multiply by our 2, that multiple out front, it simplifies those parentheses, it simplifies them out, and that's why we did that there. Now we can go on and factor this here. And what we end up getting is x, because that's what it's going to be. And then really, it's whatever number is inside the completing the square before we simplify, so it's plus 2. So 2 times x plus 2 squared, well, negative 8 plus 7 is negative 1. So we get this here. And this, again, is lining up with our a times x minus h squared plus k. Now, our vertex is the point h comma k. Comma k is normally our vertex. Now, if we look at this here, well, h is inside the parentheses. So here it's 2. But again, we're normally talking about negative h. So since it's positive 2, it means our h value is negative 2. It's the opposite sign because since it's negative, my marker, since it's negative here, it means this here has to be negative because it's the opposite sign. It's opposite of what we think. Now the k value is outside, and here we have minus 1, so it's just going to stay the same, minus 1. Now our axis of symmetry is x is equal to h. Well, we already said h is negative 2. And that's it. So it only asks for the vertex and the axis of symmetry. So that's all we have to do for this here. And so we're done. So this here is a little bit more complex way to do this, but this is all we have here. That's all we have to do for this here. And we'll find a better way to do it if we're not given it in standard form. Now here, so it's going through, so we split that up like it showed. Then we use the completing the square. Multiply on the outside, so regroup the terms, and simplify. So here, our axis of symmetry is x equals negative 2, and our vertex is at negative 2, negative 1. Now, there can be more examples of this here, so we could have, say, f of x equals negative 3, x minus 3 squared plus 9. Get that out of the x. So we could start off with something like this here, and if we start off with this here, well, it's not too bad. It's saying the vertex is our h comma k. Now the h value is inside the parentheses, and since it's already x minus 3, that means we just take whatever the value is inside. So here the value of h is just 3. So we take the opposite. Since it's negative inside the parentheses, it means it comes out as positive. And our k value is on the outside, so it's just 9. And as what they call the axis, or the axis of symmetry, would be x equals h. And we just said the h value is 3. And that's it. So if they gave it in this form, it's just easy. We pull it down like this here. Now, say it wasn't in standard form, where we have kind of like this one here. What can we do? Well, there's another way to do it to find x-intercepts. Find where it's 0. Factor, remember. Okay, so we'll get to that in a second. I thought that next slide was coming up, but it's not. So this here, to find x-intercepts of the graph, you must solve it. So we want to try to find what values of x make it 0, because x-intercepts and solutions are the same thing. When this cannot be factored, you can use the quadratic formula. We've already gone over that. And remember, however, the parabola may not have any x-intercepts because it may be above or below the x-axis. Finding maximum minimum. Now, this here is what I was thinking of. This here, negative b over 2a, comma f of negative b over 2a, is the vertex. Negative b over 2 of a, comma f of negative b over 2a. So let's go back all the way to this here. And I'm going to erase all of this here. and this here. Erase all that. So what they just said is the vertex for a non-standard function is negative b over 2a, comma, f of negative b over 2a. And it doesn't do fractions well, so I'm just writing it like this here. So let's try this out. Let's see how this works. So negative b over 2a. Well, our normal function, our normal quadratic is ax squared plus bx plus c. Let's put the 2 up into the exponent. So this here. So this kind of lines up. So our a value in this case is 2. Our b value is 8. So if I wanted to find the vertex, so the x value of the vertex, I would do negative b over 2a. Well, our b value in this case is, so we'd have negative 8 over 2 times 2. That'd be negative 8 divided by, well, 2 times 2 is 4. Negative 8 divided by 4 is negative 2. Well, hey, it kind of lined up, didn't it? Because when we solved this the first time, we found that the x value of the vertex was indeed negative 2. Now, you're probably wondering what is f of negative b over 2a? Well, what is negative b over 2a? It is negative 2. So what it's telling us is we want to take f of negative 2. So what we're going to do is we're going to plug negative 2 in for each one of these x's. So we'll have 2 times negative 2 squared plus 8 times negative 2 plus 7. So we're just plugging it in. We're plugging it into the function. Well, negative 2 squared is 4. Negative 8, or 8 times negative 2 is negative 16 plus 7. 2 times 4 is 8 minus, well, negative 16 plus 7 is negative 9, and 8 minus 9 is negative 1. So we get that the vertex for this is negative 2 comma negative 1. And that's our. So as you see here, we do get the same vertex value as we did if we rewrote it in standard form, but this here is a little bit easier. It's a little bit easier when we're trying to find this. So we can use this way to find the vertex instead of having to rewrite it out in this form here. We don't have to do it that way. So we have this here. Now, with a quadratic, a basic quadratic function, because a quadratic function is either going to open down or it's going to open up. It's going to open in one of two directions. And since it only opens in one of two directions, we're either going to have a minimum or a maximum. Because when it opens down, we're going to have a max, and when it opens up, we have a minimum value. There's only one spot where it can be at, and that minimum or maximum value is at the vertex. It's the y value of the vertex. It tells us what the minimum or maximum value of the function is. And that's it. Now, I'm not going to worry too much about the height of the baseball, and I think that's it. So the problems are here. They're also in Google Classroom. Now, I haven't had a chance to look at the book itself, so hopefully I have covered everything that these problems are going to cover, and don't do anything that is graphing. And I will be able to double check this and go over it whenever I get back into the classroom next. So hopefully we covered everything, and I hope you all have a good rest of your day, and give these homework problems a try. I will cover any questions that you have when I see y'all next.